Hello friends, in today's video lecture we are going to discuss Liang-Barsky line clipping algorithm. Now Ling and Barsky have developed more efficient algorithm than Cohen-Sutherland algorithm. Now you all have a question, what is the difference between Cohen-Sutherland and Liang-Barsky line clipping algorithm? So let me remind you, in Cohen-Sutherland algorithm, we will uh, we will draw 9 region, and from that we used 4-bit code for each 9 region. That way we can use the line clipping algorithm, and Liang-Barsky have developed more efficient method by parametric equation, and this is the major difference. So let's discuss Ling and Barsky line clipping algorithm. Ling and Barsky have developed more efficient method than Cohen-Sutherland algorithm using parametric equation. So what did Ling and Barsky developed? It developed efficient method than Cohen-Sutherland algorithm using parametric equation. Using parametric equation. What are the parametric equation? As we given as x is equal to x1 plus t del x, y is equal to y1 plus t del y, whether is 0 is less than or equal to t or is less than or equal to 1, where del x means length, x2 minus x1, and del y is equal to y2 minus y1, where del x is equal to length of x-axis and del y is equal to length of y-axis. The point clipping condition for Liang-Barsky approach in the parametric form can be given as, what we have to find? The point clipping condition for Liang-Barsky approach in the parametric form can be given as xw minimum is lesser equal to x1 plus t del x is less than or equal to xw max. Similarly, yw minimum is less than or equal to y1 plus t del y is lesser or equal to yw maximum. Liang-Barsky expressed these 4 inequalities with 2 parameters p and q as follow. What did they do? They expressed these 4 inequalities with 2 parameters p and q as follow. That says T Pi is lesser equal to Qi, where I is equal to 1, 2, 3, 4, where parameter P and Q are defined as, in this equation, where parameter P and Q are defined as P1 is equal to minus del x, Q1 is equal to x1 minus xw minimum, P2 is equal to del x, Q2 is equal to xw max minus x1, P3 is equal to minus del y, Q3 is equal to y1 minus yw minimum, and P4 is equal to del y, Q4 is equal to yw max minus y1. By following observation can be easily made from above definition of parameters P and Q. Following observation can be easily made from above definitions of parameter P and Q. For this, if P1 equal to 0, then we can say line is parallel to left clipping boundary. Line is parallel to left clipping boundary. If P2 is equal to 0, then we can say that line is parallel to right clipping boundary. If P3 equal to 0, then line is parallel to bottom clipping boundary. Line is parallel to bottom clipping boundaries. If P4 equal to 0, then line is parallel to top clipping boundary. Clear? Now, if Pi is equal to 0, then line is parallel to one of the clipping boundaries corresponding to the value of I. Now, if Qi is less than 0, let me correct. If Qi is less than 0, then line is completely outside the boundary. Line is completely outside the boundary and can be eliminated. So whenever we got the value of Qi is less than 0, the line is completely outside and boundary can be eliminated. Now, if pi is less than 0, then line proceeds from outside to inside of the clipping boundary boundaries. And if pi is greater than 0, then line proceeds from inside to outside of the clipping boundaries. So we have to remain this all rules is that p1 equal to 0. If p1 equal to 0, line is parallel to left clipping. If p2 equal to 0, line is parallel to right. p3 equal to 0, then it will be parallel to bottom, and p4 equal to 0, then it will be top. Like it is just like Cohen-Sutherland algorithm, right? This is the 4 condition, and pi equal to 0, then line is parallel to one of the clipping boundaries corresponding the value of I. It's depend of value of I. If qi is less than 0, then line completely outside and we can eliminate that boundaries. Then pi is less than 0, then line proceeds from outside to inside, right? And if pi is greater than 0, then line proceed from inside to outside, right? Therefore for non-zero value of pi, the line crosses the clipping boundaries. Value of pi, the line crosses the clipping boundary and we have to find parameter t. The parameter t for any clipping boundary I can be given as t is equal to qi divided by pi, where I is equal to 1, 2, 3 and 4. Now, Liang-Barsky algorithms calculate two values of parameter. It's calculate two values of that parameters t, that is t1 and t2, that define that part of the line that lies within the clip rectangle, right? What will be the t1 and t2 defines? It's defined that part of the line that lies within the clip rectangle. The value of t1 is determined by checking the rectangle edges. Value of t1 it determines by checking the rectangle edges. It determines by checking the rectangle edges for which the line proceeds from outside to inside. Now that is P is less than 0. If value of T1 taken as largest value among various value of intersection with all edges, on the other hand the value of T2 determined by the checking the rectangle edges for is checking the rectangle edges for which line proceeds from inside to outside, that is P is greater than 0. The minimum of calculated value is taken as a value of T2. Now if T1 is greater than T2, then we can say that line is completely outside the clipping. And it can be rejected. If T1 is greater than T2, then line is completely outside the clipping window and it can be rejected. Otherwise, the value of T1 and T2 are substituted in the parametric equation. To get the endpoints of the clipped line. This way Lind and Barsky algorithms works. Now let's see the algorithm for Liang and Barsky. What will be the steps? How we calculate the algorithm? Now step number 1, what we have to do first, that is read two endpoints of the line. What will be the point? That is P1 x1 comma y1 and P2 x2 comma y2. Now second one is read two corners left to top and right to bottom of the window. We can also say xw minimum comma yw maximum comma xw max comma yw minimum. Got it? We have to find xw minimum, yw max, xw maximum and yw minimum. Got it? Now what is the step number 3? That is calculate the values of parameters. Calculate the value of parameters Pi and Qi for I is equal to as we look the theory, that is 1, 2, 3 and 4, such that. So we have to calculate P1, P2, Q1 and Q2. P1 is equal to minus del x and Q1 is equal to x1 minus xw minimum. P2 is equal to del x and Q2 is equal to xw max minus x1. Q1 is equal to minus del y and Q3 is equal to y1 minus yw minimum, and Q2 is equal to del y. Q4 is equal to y max minus y1. Now fourth step of this algorithm, that is we have to find conditions like Pi is equal to 0, then the line is parallel to ith boundary. Now if Qi is less than 0, then line is completely outside the boundary. Hence, we have to discard the line segment and go to stop. Else, check whether line is horizontal or vertical, and accordingly check the line endpoints with corresponding boundaries. If line and point lie within boundaries area, if line and point lie within the bounded area, then use them to draw line, otherwise use boundary coordinates to draw line, otherwise go to stop. This will our fourth step. And what is the fifth step of this algorithm? Step number 5. Initialize value for T1 and T2 as T1 equal to 0 and T2 equal to 1. And 6th point, that is calculate values for Qi minus divided by Pi for I is equal to 1, 2, 3 and 4th. Now step number 7, select value of qi divided by pi, where pi is less than 0, and assign maximum out of them as t1. And step number 8, select values of qi minus pi where pi is greater than 0 and assign minimum out of them as t2. Step number 9, that is, if t1 is less than t2, calculate the endpoints of the clipped line as follows, that is, x1 is equal to x1 plus t1 del x, x2 is equal to x1 plus t2 del x, y1 is equal to y1 plus t1 del y, y2 is equal to y1 plus t2 del y, and draw the line xx1, yy1, xx2 and yy2. Then step number 10 is stop. So this is the algorithm to find parametric equation and find the all points for Liang-Barsky line clipping algorithm for more efficient points. So what are the advantage of Liang-Barsky line clipping algorithm? That is, it is efficient method than Cohen-Sutherland algorithm, right? So this is the algorithm, and in next lecture we will see the example of Liang-Barsky algorithm. Thank you for watching.